Good morning, students. In this class, we discuss about Newton-Raphson method. First of all, we discuss about Newton-Raphson method. So, it is based on Taylor series. It is based on Taylor series. And partial derivatives. Newton-Raphson method is very fast method and number of iterations required are very less. So, number of iterations required in this method are less. So, less memory required, less computational memory required, and it takes less time, to solve the nonlinear equations. This method is not affected by due to first stage selection of select path, and second is size of power system. You can say size of power system. So this method can be used for large power systems for the solution of nonlinear equations in load flow analysis. So this is the basic about Newton-Raphson method, in which we use Taylor series and partial derivatives, and it takes less memory and less computational time, and it is not affected due to size of power system and selection of select path. Now we discuss about the method, how we can solve the nonlinear equations using Newton-Raphson method. In this method, we transfer nonlinear equations to linear equations. Using Taylor series and partial derivatives. Simply, first of all, in this method, we convert nonlinear equations into linear equations using Taylor series and partial derivatives. Now we discuss about the method. let me consider let's consider a n bus power system, in which one bus is slack bus. One bus is slack bus. So remaining buses are n minus 1. So remaining buses are n minus 1. At each bus we can write equations, linear and non-linear equations. So let me consider unknown variables are x1, x2, x3 dot xn, and specified variables are y1, y2, y3, y4, y. So in n bus power system, one bus is slack bus, so remaining buses are n minus 1. Now when we find nonlinear equations at each busage, so there are 2n nonlinear equations. Now in nonlinear equations we consider x1, x2, x3 dot xn. These are the unknown variables, and y1, y2, y3 that yn are specified variable. So equation in terms of unknown becomes fy is equal to y1 is equal to f of x1, x2, x3 dot xn, y2 is equal to f of x1, x2, x3 dot xn. Similarly, y3 is equal to function of x1, x2, x3 dot xn. For similar, yn is equal to function of x1, x2, x3 dot xn. Means y1, y2, y3 dot yn are the function of x1, x2, x3 dot xn. We know that Newton-Raphson method is also a iterative method for the solution of non-linear equations. So first we consider initial value of iteration. Next we write let initial value for iteration or first iteration we assume x10, x20, x30, x40 dot xn g. So first iteration we assume the value of unknown variables x10, x20, x30, x40 dot xn g. Now we put the values in the equations. Now the equation becomes y1 is equal to y10 is equal to f of x1 0, x2 0, x3 0, x4 0 dot xn 0. y2 is equal to f of x1 0, x2 0, x3 0, x4 0 dot xn 0. Similarly, yn 0 is equal to f of x1 0, x2 0, x3 dot and xn. Equations are represented by assumed value of unknown variables. Now we go towards solution. For next equation, we change the values of x1, x2, x3 dot xn to get a valuable result. So now in second iteration we change the value of unknown variables changes. So change is delta x1 is equal to x1 0 plus del x1, x2 0 plus del x2, x3 0 plus del x3, x4 0 plus del x4, xn dot xn 0 plus del x. In this way, the value of unknown variables changes. The next term, here we can also write 0, 0, 0. Now we put this new value of unknown in the given equation. So equation becomes y1 is equal to y11 is equal to function of x10 plus del x10, x20 plus del x20, x30 plus del x30 dot xn0 plus del xn. Similarly, y2 is equal to f of x10 plus del x1, x2 plus del x2, x3 plus del x3. Similarly, xn plus del xn. And yn is equal to f function of x1 plus del x1, f x2 plus del x2, x3 plus del x3, x4 plus del x4, dot xn plus del xn. In this way, new equations are y11, y1, y21, y3n1 and yn1. Now we expand the equations using Taylor form. Then we can find new equations. Now, next is now we expand the equations using Taylor series. So equation y1 is equal to f of x10 x20 x3 dot xn0 plus function of plus del x10 del f1 upon del x1 del x20 del f2 upon del x2 dot del xn0 del f upon del xn in this way. So in this way we expand all the equations using Taylor series. Similarly, y2 becomes function of x10 x20 x30 dot xn0 plus del of x10 function del f2 upon del x1 plus del x20 del f2 upon del x2 dot del xn0 del f upon del f2 upon del xn, and similarly yn is equal to function of x10 x20 x30 dot xn plus del x1 del fn upon del x1 plus del x2 del fn upon del x2 dot del xn del f upon del xn. So in this way we expand all the equations, nonlinear equations, and we convert these nonlinear equations into linear equations. So in next term, next step is we can write these equations as we put this function towards the RHS LHS, then we can write as equal sign minus f2 is equal to. So these equations can also be written as y1 minus function of x1 x2 x3 xn is equal to del x1 del f1 upon del x1 x2 del f2 upon del x2 and xn del f upon del xn. 1n, this is the function first, not n, 2 or n. Similarly, y2 is function of x1 x2 x3 xn is equal to del x1 del f2 upon del x1 x2 del f2 upon del x2 plus dot del xn del f2 upon del xn, and yn is equal to yn minus f x10 x20 x30 and xn0 equal to del x1 del fn upon del x1 del x2 del fn upon del x2 dot del xn del fn upon del xn. Now this equation can be written in matrix form where some variables are unknown and some variables are known or specified. So now we write these equations in matrix form. F1 F2 F3. Now Write the equations in matrix form. In matrix form. In matrix form. In matrix form, we can write the equations as y1 minus f1, x1, x2, x3 dot xn, y2 minus f2, x1, x2, x3, xn, y3, f3, x1, x2, x3 and xn. Similarly, yn minus fn, x1, x2, x3 dot xn is equal to. Now we can write del f1 upon del x1, del f1 upon del x2, del f1 upon del x3 and so on. We can write del f1 upon del xn, del f1 dot del f1 upon del xn. Similarly, for y2 is del f2 upon del x2, del f2 upon del x1, x2, del f3 upon del x3 and del fn upon del xn. F1, F2, 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 F1, F2. Similarly, del F3 upon del X1, del F3 upon del X2, del F3 upon del X3 dot del Xn upon del F upon F3 upon del Xn and del fn upon del x1, del fn upon del x2, del fn upon del x3 dot del fn upon del x, and change are del x10, x20, x30 dot del xn 0, where x1, x2, x3 dot xn are the changes in unknown variables which are required to obtain the solution of the nonlinear equations. Now this matrix is in the form of B is equal to JC. B is equal to J dot C, where J is Jacobian matrix. Where J is Jacobian matrix. Jacobian matrix. C matrix is unknown variables and matrix B is functions, specified variables. So this is the Newton-Raphson method for the solution of unknown variables. Thank you for today's class.